In the second lesson, we are going to learn the logarithms, the relation between logarithms and exponents. Logarithms, logarithmic functions, logarithms, inverse of exponents. Inverse of exponents. What does it mean? If fx of, from the fx is equal to y, this one from the 10th grade or 2nd grade. If you replace x, y, y, here x is equal to, you clean the fx, like you clean, and x becomes alone, and you send the x to the other side, but it get minus sign here. It is f inverse. Now x is equal to f inverse y. Okay, this means inverse. Here, if we explain simply the logarithm, it says a to the power of y is equal to x. This implies that this base comes as a logarithm base, and here this comes to this side. Y is equal to logarithm base a x. Example for this one here, 2 to the power of 3, we know it's equal to 8. Now here we are going to find the logarithmic form of this one. Here 3, like it falls down, is equal to logarithm, the base of the exponent becomes the base of logarithm 2, 8. If you try to understand the logarithm here, this expression, what is written here, finds the power. We are finding the power here. What is the power? Here the power was 3. With this operation, with logarithm operation, you are finding the exponential power, which is equal to 3. If I give some examples here, firstly let's write the logarithmic expression, and we should prove that one is equal to 2. Logarithm 100 is going to be equal to 2. How it should be? This base should come, if you are finding the inverse of it, 100, is it equal to 10 to the power of 2? Yes. Or logarithm base 3 1 over 27 is equal to minus 3, which means this base goes here, base of exponent, so it will be like this. 1 over 27, is it equal to 3 to the power of minus 3? 1 over 27, is it equal to 1 over 3 to the power of 3? Yes, 3 to the power of 3 is going to be equal to 1 over 27. So this is also true, 1 over 27. Okay, the third one. Let's leave a space for the third one. Okay, then here logarithm base 2, 1. Is it equal to 0? Yes. How to find this one? 1, this goes to base 2 to the power of 0. So 1 is equal to 2 to the power of 0. Yes, 2 to the power of 0, it should be equal to 1. If we continue with the next example, here this number shows the base, and this number b shows the power. Base and power. 2 to the power of logarithm 2x, normally if it is equal to 3, it means that x is equal to 2 to the power of 3. Here I'm showing that one again. If I make this one 3, the base, as you see, it becomes the base of exponent. It becomes, or if I make it 4, 4 to the power of 3. Here 4 to the power of 2. 4 to the power of 2. Here this base, somehow here it comes to this side. Here you need to know one information, and then logarithm base e. Base e, exponential base it is called, and it is approximately 2.71, and constant of natural logarithm. It's like pi. Pi, you know, approximately 3.14. It's approximately, and this number is also approximately 2.71. It's continuous number here, 3.14, 15. It continues till infinity. Also 2.71 continues till infinity. Second part, base 10. When the base 10, the base is not written, or when the base e, base is not written, instead of base ln e. So when you see ln x is equal to 2, it means that you're going to understand that logarithm base ex is equal to 2. Or when the base is 10 here, it is not written. That's why when you find the logarithmic expression 10 to the power of 3, you're going to say. Here with the example, next example, we'll understand better. Now the base of the logarithm is 4, it's equal to 6. So this is going to be 4 to the power of 6, which is 4 to the power of 6 here. Okay. Base is 8, logarithmic base is 8, and x, it should be equal to 8 to the power of 11. Logarithmic base is 3, and here this is 2, so this is 3 to the power of 2. Logarithmic base is 4, and the value is equal to 0, so it should be 4 to the power of 0. X is equal to, and this is the last one, it should be. We are going to write the inverse of it. If 2 to the power of 3 is equal to 8, what is the, if 2 to the power of 3 is equal to 8, what is the inverse of it? 2 to the power of 3, if it's equal to 8, we should send 2 to logarithmic base and 3 falls down. 3 falls down. 3 is equal to logarithm base 2, 8. Or 5 to the power of 0 equals to 1 when you say 0 falls down. 0 is equal to logarithm base 5, 1. Or 3 to the power of minus 2. Minus 2 equals to logarithm base 3, 1 over 9. It's going to be, these are the logarithmic expressions of the terms. Okay, here the inverse part. Now 2 to the power of x is equal to 3, or I can change this one. 4 to the power of x is equal to 3. This means that logarithmic base also it's going to be 4, and the what is written in the argument part, in main part here, it's going to be equal to 3. Now 8 and 14 I have. I'm going to check 8 and 14. Do we have here? Here it should be. 6 and 11. So logarithmic base, it should be 6. Logarithmic base is 6. This one. Logarithmic base is 9. This one. Logarithmic base is 8, but it is 5 here. This one. And this is going to be logarithm base for 13. Okay. The next one. Logarithm base x27 is equal to 3, and solve the x. So here 27 is going to be equal to x to the power of 3. X to the power of 3. And we know that 3 to the power of 3 is equal to 27 and x to the power of 3 on this side. So here if the bases, if the powers are same, bases must be same. We know that one. X should be equal to 3 if we cancel them. Okay. X is equal to, for the second question, 4 to the power of, this is the power, to the power of 1 over 2. Okay. x equals to square root of 4, you know, to the power of 1 over 2 it means, and x is equal to 2. Okay, the last one, here again the base is 4, the power is x, 16 is equal to 4 to the power of x, and 16 equals to 4 to the power of 2, we know that one, so x is equal to 4 to the power of 2 is equal to 4 to the power of x, the bases are same, powers must be same, x is equal to 2. If we solve the next question, calculate the logarithms, it says here, logarithm base 2, 4 is equal to what? We are going to try to find this one, is equal to what? So for each term I'm going to use x. Logarithm base 2, 4 is equal to x. 4 is equal to 2 to the power of x, and 2 to the power of 2 is equal to 2 to the power of x. So the bases are same, powers must be same, x is equal to 2. These two powers, they are equal to each other. So the first one is equal to 2. Okay. The second one, logarithm base 3, 1 over 9 is going to be equal to 3 to the power 1 over 9 is equal to 3 to the power of x. 1 over 9 is equal to 1 over 3 square, but the bases are not same here. 3 to the power of x, 1 over 3 square. But if I write this up, the power becomes minus, and it is equal to 3 to the power of x. Okay, then x will be equal to minus 2, which means that logarithmic expression result here equals to minus 2. Okay, for finding this one, we should solve one by one. What is in bracket? First we should solve that one, then the value we should check here. So I'm going to start with logarithm base 3. I'm going to start with logarithm base 3, 9 is equal to what firstly? It's going to be equal to logarithm base 3, 9 is equal to x, 9 is equal to 3 to the power of x, 3 square is equal to 3 to the power of x, so x becomes equal to 2. Here x is equal to 2. Then if x is equal to 2, if this is equal to x, and if x is equal to 2, it means that logarithm base 2 logarithm 3, 9 is equal to logarithm base 2, this expression we found is equal to 2. Here we are going to learn in the properties also, logarithm base 2 is going to be equal to 1, but let's prove that one also is equal to y, let's say. Then logarithm base 2 is equal to y, and 2 is equal to 2 to the power of y, and here the power is 1, we know that one, so y is equal to 1, it's going to be. It means that this expression is equal to 1. Okay, here the homework page, but we are going to solve these homework questions in the classroom